Hey. All right. Welcome to Hard Drive 32. Whole new week, and kind of considering this more or less the first day of doing some true legit streaming. I need to have that mic down so you guys can hear me better. But yeah, so Hard Drive 32 is going to be a channel dedicated to working on indie games, primarily kind of like 32-bit retro throwback games, similar to like PlayStation era, that sort of thing. And my background is I've worked as an art director at a mobile video game company for 5 years. And then after that, I was actually the art lead at a regional business magazine. And kind of like my background is primarily graphic design. I was really fortunate and lucky to work in a small indie team and kind of like learn both skill sets. Even still, it's been a few years since I've done indie game dev. So kind of just this channel is dedicated to watching my journey from beginning to end. And honestly, connecting with you guys out there to where if you have any personal projects you're working on, I can help you, you can help me, and we can cheer each other on. And that's it. So today, what we're going to work on is Bolt, Unity Bolt, because I am an artist. So I'm an artist, not a programmer. I did have some background in it when I was working at the studio. However, my goal is to make a prototype game using Unity Bolt, a visual programming language. I'm not the type of person to say, oh, you don't need programmers to pull off a game. I don't think we're anywhere near that. Not saying that at all. And this is going to be a little bit slipshod how it's put together, but the idea is I just want to see the merits of the game that I'm wanting to create. And I think creating a prototype, even if it's a hacky prototype using visual programming, is better than nothing at all. And then afterwards, if the game idea has merit, pursuing some freelance programmers and that kind of thing to begin building a team out. Because I love working with programmers. It's funny, even though I'm an artist, there's kind of like, I'll do a little slight aside actually. So there is kind of in the video gaming world, there's from what I can tell, from what I've experienced, there's a little bit of a schism between artists and programmers, and both being kind of envious of each other or not quite having a common ground with each other. But the nice thing is, and I think this is probably true of a lot of graphic designers, is graphic design is very much a goal-oriented art. If it doesn't accomplish what you set out to do, then it's not worth making. And art doesn't have to be pretty in graphic design to accomplish a goal. Graphic design artists we're just very goal-oriented in the same way that programmers are very goal-oriented. They want the game to run well. They want it to be bug-free. They want it to be optimal. They want it to be fast. All those kind of things. And so I love working with programmers because I found, honestly, our minds work pretty similar in a lot of ways. So anyways, that's all alongside that to say that if this game is great and worthy enough for me to bring on a programmer, then you'll get to see me try to find a programmer out there and take it from there. But for today, this is going to be an artist trying to learn visual programming. So we'll see how it goes. And along the way, I'll actually take the time to break down common terminology for you guys, because I do want this channel to be somewhat like, if you're watching this and you've never seen like how the sausage is made, how you make a video game, I'm going to use this as like an opportunity to give you guys a peek into some of the general concepts and techniques that go into making a game, and why games are so difficult to make. But it's worth it. It's always worth it. All right. So this is Unity's Bolt platformer tutorial. And Unity has, for their visual programming Bolt. That's the name of their visual programming language. And I'll show you in a moment what visual programming looks like. It's almost like Legos with code, visual Legos with code. And if you were using Unreal Engine, it would be Blueprints. And Blueprints, by the way, is fantastic. Absolutely fantastic. But I'm using Unity because that's what my history is in Unity, as well as the fact that the game I'm trying to make is a 2D platformer, which Unreal is okay at. Unreal Engine can be fantastic at anything, but Unreal Engine is very much like when you're first starting out. Unreal Engine's great at first-person shooters, racers, like a number of different like common gameplay stereotypes. But as soon as you start getting into things that Unreal Engine isn't good at, for example, just a 2D platformer, then things get a little more difficult to do. Whereas Unity, you start with almost nothing and you build it up, which is kind of nice too, because like you could just put in what you need. So where I left off on was the character controller. And the character controller is what it sounds like, it controls the character. And what you're doing is, in code, you're trying to translate the character moving around in 3D space and attaching it to keys on the keyboard. To say, when I press the A key, for left, move left, translate that character, move that character left in the X direction. And X is horizontal in 3D space. Y is length, Z is depth. And I might have just reversed those two, but you get what I'm saying. Alright. So this was, this portion of it, I was creating a flow machine. The way I would describe code, flow machine is a very nice name. For those that don't understand, like, I would say most people understand that code is text, 1, and 2, that code, goes in an order. But what people don't understand is that code is like a river, and you're sending little boats down that river with commands on them, and they're going to reach their destination and deliver that command. And what's amazing is that it has to be primarily, at most often, sequential. All those little boats have to go in order. And so the full extent of that is difficult to quite understand until you've worked in the game development area, and you get a peek into what programmers have to go through to get it set up to where all these commands go through correctly. All these boats arrive at their destination quickly and on time. But okay. All right. Then at this point, what it had me do was it had me create what's known as a float, and I'll show you guys here. Let me just show you. It had me create a float, and it was, let me make sure I get this right. Yeah, for speed. Right here, in this bottom right corner here. Just so you guys know, here's a fun thing for non-programmers that's really helpful to learn. When it comes to numbers within code, there's a number of different things, but two of the big ones are float and integers. Integers are whole numbers. Floats are, so like an integer would be 1, 2, 3, 4, 5 whole numbers. Floats would be 1.22223, 1.22224. It's everything in between. And floats are computationally harder on your system. But for anything you want to move, like transition smoothly, you're going to want to use a float, because otherwise, if it was an integer, your character would jump around from location to location to location. And if, for example, you're working in a tile-based game where your character is like a chess piece moving from square to square, that's perfectly fine. But if you're working in a game where the characters smoothly move around their environment, you're going to want it to be a float. So they made me make a float, and they set the value to 5. The value doesn't necessarily matter so much as you're setting a baseline number. And then they had me create input get access, a line of code here, and say, hey, look for that x-axis and see if the player is going to mess with the moving the character left and right. And this is, by the way, there's going to be times of silence and stuff like that, just as we're beginning. But here's the thing. While I'm working on stuff, I'd love for anybody out there to put me in a side window and you load up your dream project and just keep working on it too. And we'll work on it together. Think of me as like your little work study buddy. So. Okay, so then. So you will notice the new unit shows up as dimmed out. This is because we're not using its value anywhere yet. So Bolt warns us that it is currently useless by fading it out. If you want, you can disable these glasses on so I can see better. There we go. Toggling off dim in the graph toolbar. Next, we need to multiply this value with our speed object variable. We can use Bolt's contextual menu to make that easier. Drag and drop the value output port of the get access unit to an empty space of the graph. Choose multiply. Literally multiply meaning multiplication. By the way, if you guys are working in Photoshop and use the multiply blend mode, it's literally multiplying the color values of that first layer onto the second layer. And if you guys know multiplication, 1 times 2 equals a bigger value. So lighter color times darker color equals darker color, hence multiply. Drag and drop the second port of the multiply unit to an empty space in the graph. I hope me burping in my mouth was not picked up on stream. So sorry. Choose variables, object, get object variable, type speed as variable name. Yeah, so ooh. Or no, wait, did I get the wrong thing? I don't. Oh, okay. Yeah, I don't quite know. Let me see. Value output port. Okay. That thing is currently, I don't know what these icons quite signify just yet, but I will. Okay, so that's a math. And math generic, yep. Yeah, times out by speed. So what's nice is they're saying get speed, so if I change this variable, like I could make it 4, and it would change this in here. Okay. To complete our movement calculation, 1, add a set graph variable unit. This is found in variables graph. Okay. Set its name to movement. Connect the result of the multiplication to its value. Input port. Connect the update node to its controller input. Okay. Okay. So update events are essentially when you're telling the computer when to send that boat down the river. So that bit of code telling update events are like, hey, do something for me, game. And in this case, we're saying like, if it detects any input, like us pressing a button to move our character, then hey, you need to do the math for that movement. So set variable. Okay. It's set. Oh, well, cool, and I can change it. I feel so dumb. Someday, one nice thing is Unity has insane documentation, and I will definitely sit down sometime and just like read through all of Bolt's documentation. So I have complete understanding of like why things work the way they do. But so far this hasn't been too bad at all. All right, so what's gonna make the boats go? An update. So this is all fine and dandy, but it's probably gonna tell us now is we've got all sorts of things like setting what key does what. Okay, let's recap what's happening here. At every frame in the update event 2, we get the horizontal input axis, which is written -1 to +1. No. So if you think of a graph, like if you're in math class geometry and you saw a grid, -1 is to the left on the x and +1's the positive on the x. We multiply it with the speed so it becomes -5 to +5, aka how fast is our character moving, and store it in a variable called movement. Okay. Our player isn't moving yet, but we know by how much it should move. Note 2 important things about it, the new movement variable. We didn't create it beforehand like we did in the player speed because we didn't need to give it a default value. Bolt supports dynamic variables, meaning you can create new variables during play mode on the fly by just assigning them a value like we just did. We use a graph variable instead of an object variable because we only ever need the movement inside this graph. No need to share it with the outside world. Now you know all the basics, creating graphs, variables, and units. Next we'll pick up some speed and get the character to move. Okay. The player prefab in the project already has a rigid body 2D component attached. All we have to do is make the player move and tell it which velocity speed to go. And we just calculate that. Okay, velocity on a 2D rigid body is a 2D vector. 2D vector means 2 values, aka x, y. There's no depth. It has a x component for the horizontal speed and a y component for the vertical speed. Because we only want to affect the horizontal speed, we'll have to keep the vertical speed intact. We need to create a new graph outlining this functionality within the same flow graph as the previous movement calculation. Make sure you have some free space in your graph to create the following. Okay. Let's move this here. To get variable. I'm gonna move this over here while I'm working for just a little bit. Okay. Okay, so first they want us to get rigid body 2D. Rigid body 2D is just referencing this character. Can I spell rigid body? Oh, I see. I need to get the velocity of it. Okay. Okay, so we're going to find out what the velocity of the character is, aka its movement. And then we want to vector 2. Oh, it's nice that it kind of detects it. Vector 2, get y. The question is, get y? Will it detect that? Get type. No, that's not right. Okay. Let's see if I just do vector 2. Okay, gotcha. Alright. So it's saying, hey, where's this character? And the X and Y. And then it says we want to get variable. So graph, of course, and specifically movement. And then we'll vector 2 create. That doesn't seem right. Let's see. No. Nah, bruh. Sorry, guys. I got some crazy news about a client I'm working for. Not bad, just one of them had something medically happen to them. Uh-oh. They're gonna be fine now. Okay. Let's see here. Vector 2 create. I'm gonna get vector 2 create. Vector 2. Let's go ahead and select that. Is it gonna be, is it not set new X and Y? So it's not, because I don't want to set the value. What am I doing wrong here? Codebase, Unity, Vector 2. Okay, Codebase, Unity. Vector 2. This is alphabetical. Where is create? Where is create? Y'all, I can't find create. This is dumb. I think set would work, but that can't be right. Oh, that's so dumb. Alright, so here's what the tutorial says. Get Y and create vector 2 are located under Codebase Unity vector 2. If I go right, create vector 2, vector 2 create. I mean, this works. This resembles their graph. It's not the same necessarily. I mean, it's the same thing. Instead of create, it's new. Maybe they changed the language on that. Oh, you know what it is? You know what it is, guys? I feel so silly. I'm doing this tutorial. So one of the interesting things about Unity's Bolt is you can set it to use either programming language, or you can use it or give it what's called human language, aka like a simplified version of language. And I realized this tutorial is using human language and not programming language. I set it to programming because it did have like a site background in it. And that's why I couldn't find create, because it's got a different naming convention. Oof. I hope that doesn't bite me later with some of these things, but well, I went hard mode by accident. That's okay. So we're gonna bind these two. Boom. All right. Here's what it says. If you have dim enabled, you'll notice all of this graph is faded out. Yep, okay. That's because we never specified when to set the velocity, the first arrow part of the set velocity. Quite simply, we want to do this after we calculate the movement so we can connect it with our previous set of units. Gotcha, okay. Okay. So what they're saying is that this here needs to go up to here, and it needs to happen here. Might rearrange these things, make it all nice and cute and clean. That is, how do you multi-select on here? Oh shoot, that's nice you can create groups in this, but that's not what I wanted to do. Okay. Okay, calculate movement, set velocity. So what they're having me do now is they're just making me organize this graph a little bit. I'm gonna put this here. Put it right there. And this graph is to get movements. So if you hold down Control and drag, you can make groups. And most programs have this, like visual programming or like Substance Designer, all sorts of things. You can create groups just to keep your visual programming code organized. So this is going to be get movement. Boom. And this one's going to be setting velocity. Not super party. That's what we're just going to try to work fast at this. And now they say, and I might have to change things, but they say it should be able to detect my movement now. It's because what it's going to do is it's going to go and I'll show you guys project settings. So, okay, project settings, and then I go to input, and you see this is like inside your project settings is where you actually change the controls for your game, and you'll find here horizontal, which it looks like left and right is what it's set to. Okay, so that's good to know. So when I press left or right, it's going to detect if I'm going negative on the x-axis, negative on the x-axis, which is the left button. So like -1 x, and that means go left. If I click right, that means go +2, +1 right. And then that will move me left or right. And then we have the multiply that we did earlier, which is our speed, that float of 5, which says, oh, I might have got something wrong earlier I said, but that's okay. But float of 5, which is say, go say it's 1x, like positive 1x, times it by 5. Now we're going faster. And so we're going to click play, and we're gonna, before I click play, if you look here, we've got ourselves an error on the console, which might prevent us from playing. We'll see. Nope, thankfully we're okay. We're going to click play. Compiling the game. Bolt, variable, declarations, get, system string variable. So it says we do have some sort of error here. Variable not found movement. Oh, what it's saying there Get variable movement. Is that misnamed? Let's find out. It says I misnamed something here. Movement, get variable movement. Oh. Okay. I forgot to put that name in there. There you go. That's the nice thing is Unity does provide you little clues as to when you have issues. Oftentimes it's not that helpful as to what I just, think like it's solved just now. But compile errors are the big problem in games. It's when your code runs into an issue. Okay, but it should be okay now. Yes. And now. Oh, look at him. And there's gonna be no hit detection here, so I'm gonna fall off the map. Oh, there is a collider on that. Great. Now I can coast on these spikes. Oh, little flags animating. We've got live people. So yeah, that's the very beginning of doing movement with a character. And for example, let's say you're doing a spaceship flying game. You would do the same exact process, except for you would, add in the other axes, like X, Y, and if it's 3D flying game, Z. So there you go, and then it would just move the character, and if we wanted to right now, so you see how he's moving now, I could unpause this game, and I could go to my speed value here, set it to 10, and it should work to where he moves twice as fast. Yep, there you go. So that's what that speed variable was, is it's multiplying the movement along the x-axis, both directions. And so you move faster or slower with that. All right, next thing. Oh my gosh, people. Getting there. Let's recap what's happening here. At every frame in the update event, so update event is like detecting if something's happening in the game, so every frame the game occurs, it's going to check to see the inputs, which, short aside, this is one of the reasons why you want to play your games to the highest frame rate you can. And for those that don't know, frame rate is almost like film, or what should I say? It's like the like a movie is typically 24 frames per second, unless you're Peter Jackson with like the Hobbit movies, and it's 45. But most movies are 24 frames per second, which means there's 24 images that are on screen to make up a second of movement. And so for video games, it's the same thing with code. Oftentimes, what happens is if your game's running at 30 frames per second, 30 times the update event will run to detect if you're pushing a button. So if you're playing a game like Valorant, that's like, just quickest reaction time you want possible, why you want to play it at 120 FPS is it will detect, it'll run that update event 120 times to see if you're moving to, fire at an enemy. So, for example, racing games on consoles right now, a lot of them are aiming to be 120 FPS on the PS5 and the new Xbox Series S and X, because racing games are so fine-grained movements. So you want your games to be as optimized as possible, so that way things like update event can check what the player is doing as frequently as possible. Nice. Okay. So what they're having us do now is they're going to use the value of if you're going negative in the X direction or positive in the X direction to make the character artwork flip. So if it's a negative direction, we're obviously going left, our character should look left, so flip the character. Cool. Looks complicated, but it's not as bad as you might think. Okay. With this, let's no, let's oh no. Oh no. This. We'll toggle between the two. Alright. So they want us to get the movement. So by getting the movement, we're like checking the variable it's producing, like negative X, positive X. Okay. And then what they want us to do is to do a comparison, which is like, hey, see if it's positive or negative. Okay. And we're gonna create a true false branch. So flow again. So it's like, hey, can you check and see if it's cool. -1. Or hey, aka going left. Let's see if I can copy paste. Yeah, I can. Awesome. Control C, Control V. Easy peasy. Alright, so got those two. And then we need to do, we need to do a one thing. Oh, can you do that? You can just double click on a, that's awesome. You can just double click on a portion to get it full screen. I remember Unity being able to do that. What the hell? It is not letting me. Okay, it's gonna do that. Well, that's annoying. Come on. That won't. Just because I copied and pasted one thing, I always have to deal with that. It's alright. Alright, true false. No, sorry. Not bool. I guess they call it branch. Yeah, branch, duh. It's called branch for true false. Oops. Make sure I get that right. Okay. So what this is doing, this select is saying, hey, what's true is -1. What's false is 1. So that's what's saying this. It's almost like setting the values of what is true and false. And then from here, we're going to if A is equal to B, and it's false. Oh, they do actually a vector 3 with the... I wonder what they're doing a vector 3 at all. Probably a cleaner. Should do that. Just dance. Okay. I'm a little confused why I'm setting the values for those, but I'll be able to read about it here in a second. That makes sense. Set local scale. Okay. Let's do scale. No. That should be transform. Okay. So the self thing is in whatever graph we put this on, the self is like the object it's on. In this case, it's a 2D character, so 2D character is self. So let's do this. Set local scale. Okay. Yeah. Let's see if this works. It'll be a dream if it works. Oh no! Of course. Alright, let's see here. Missing input value for condition. Let's see here. What shenanigans did I miss here? Oh, yeah. I'm so silly. Yes. Yeah, it's saying if A is bigger than B, aka if A is larger than 0, then we go down this path, which is, it looks to see if things are -1 or +1 on the x-axis, and then can flip characters. Let's see here. Let's save and clear all my errors. Not a thing. It's not working. He's not looking the right way. He's gotta go off because he can't take it. Okay. So messed up somewhere. To where somehow there's something with, I feel like I messed up somewhere with the scales here. The comparisons to see if we get this right. Oh my gosh. Okay. At least I'm not doing band coding. So coding, you mistype a single letter. Depending on how strict the code is, the programming language, like with C++ or C#, you can just have to take forever. Okay. True, false. Yeah. We are going to set local scale and self, correct. And it's a vector 3, yes. And okay. Oh no, it's all right. I don't like that. Woof. Woof when things are right. Well, there we go. How do you, let's see how I delete a branch on this. How do you delete a branch? No? Gotta look up how to disconnect a branch in Unity. Can't be that hard. Right click. Oh, that's the hardest thing I have to do. What a dope. Alright, right click. Yay! We did it. God, by the way, I'm a fiend for Monster Energy drinks. They're so good. A little sugar candy water. Alright, let's click play and see if this works. Oh my god, I'm so happy. His little eye is moving. Go, buddy. Now hide behind the tree. He's a little shy. Oh, hi. What are you doing here? Do you like where this is my house? I don't know why I chose to live here. I'm stuck in this island, surrounded by spikes. I do got a little flower. It smells good. Anyways. Let's go. Alright. We got movements, we got them to be flipping because they're changing the scale to flip him. So use a piece of paper and flipped him. It makes him go left and right. Now let's see what we got here. Last part of our movement graph will be able to play the run animation. Oh yeah, this gets in the state machines. One of the craziest things is state machines. Animators, man, they've got their whole other dealio because the relationships you have to set up for animations to transition from one to another is usually controlled by a state machine. And for what I'm going to be making, this could be fairly simple, you know, jumping, falling, whatever. But if you take an example, like, I think The Last of Us 2 animations does Joel have in Last of Us 2? Oh god, there's like spoilers on the screen, I can't even block it. Alright, I don't even wanna leave up spoilers up on the screen for too long for Last of Us. But just imagine setting up this like little relationship chart where this hurt animation flows into the idle animation, and that idle can transition to a jump. Imagine that, setting that up, no big deal. But then imagine doing that for tens of thousands of animations, like tens of thousands of little blocks that transition to one another. That's what's so insane about AAA games nowadays, like a Red Dead Redemption 2, is there's so many thousands of animations for a single character, and you have to create the graph chart as to what can connect with what. Alright. Oh good, they already set up the animation controller. Or animator controller. Great. All we need to do on both ends is to pass our movement speed to the animator. Because we're passing a speed and not a direction, we'll need to make our movement variable absolute before passing it. This way, if we're going left at -5 movement, we'll tell the animator we're going at 5 speed. Okay. And that's like how fast the animation clip will play. Create the following graph to the right of our previous graphs. Okay. Also, I'm going to take this time here to do, let's make a new one. That. Okay, get variable movement, absolute. It's just copy and paste, that's what's good for. And what needs to set it correct? Or no, make absolute. Oh no, what have I done? Okay. And then we're gonna... Let me see if I can just guess it. So animator. Set float. Yeah, there you go. And float in this case is like just telling it to play the, or to set the speed of the animator, but that's not good enough. More than likely we're gonna have to tell it to play the animation clip too. Yeah, okay. This is saying we need to connect both our flipping character as well as our just like walking normally. So both of these here, because you know we want them to walk both direct, be able to walk either. Oh shoot, we'll want them to walk either direction. So I think that should be all I need to do. Okay. Yeah, if I organized it well enough, it'd look like that. Now, what's interesting to me, set, float, speed works. Does that mean they named their character's animation, their walk animation speed? Let me check. So if I go window, actually there's an even easier way to check this. I go down to animator here. Walk, player walk, speed. Interesting. All right, but now let's see if our little buddy can walk. His first steps out in the world. I'm so proud of him.
I'm walking, Daddy. You gave me the ability to walk.
And I totally glitched out. Wonder if that. Well, he's working. Look at the little guy walk. Oh, he's so happy. He puts his arms out. That's like that's the best he can do. That's his best skipping. Oof. And look at the Z fighting of all the objects clipping with him. So the reason, by the way, I'm gonna guess anyways, the reason why, yeah, totally called it. The reason all of these objects are flickering with him is that they're on the same plane. So let's actually just real quick, because I care so much, just really quickly move that back. Anything in the background should stay in the background. And this won't change anything as far as like when you're looking. Platform. Move this back. But if you look, when I click play, hopefully it won't fall. It shouldn't. Oof. I guess he does seem to be. Sorry, the reason why that happened is I think the camera depth. Huh. There we go. All right, short aside. I just wanted to fix those little flowers to where they were not flickering with him. Okay. And they're also, it looks like, even though I have this, oh man. Yeah, I'll play around in this later. There's like a sort order in 2D games where, oh, I was so silly. I had it all reversed. So let's move this back. Oops. Foliage. I'd love to know if you pronounce it foliage or foliage or foliage. Spoilage. I don't know how to pronounce foliage. There we go. Now he's walking in front of the trees. Good. What a pretty little lad. Now, we got him walking. We got our little guy controlling. Let's see what he's got in store for us next. Boom. Jumping. All right. He's got strong little legs. He can jump. see, because our player is a physics-driven rigid body, implementing jump is as easy as adding an upwards vertical force. That's how I always describe when I jump in real life. I'm just going to use some vertical force here, guys. First, create a new float variable called jump and give it a value of 12. Okay, so I'm going to go back to code mode. Sorry, cute cartoon characters. To this character, we're going to add a new variable called jump and float 12. So it's going to likely multiply the force by 12. And then below our movement graph, add a new graph with the following units. Okay, so on button input. So when it detects us, press the jump button. Ooh, stretch. Okay, get variable jump. Vector 2, add force. Okay. Oh, my brain. Okay. Get variable. Well, that works. Get jump. Vector 2. Vector 2. New. Right? Right. Set the Y because we want them to go upwards, not left and right. And on button input. And we want him to jump. I think that's what it. And then rigid body. It's going to do some force and impulse it. (2D). Add force. Ooh. That's a little different than I thought it would be. Add force self. There's no mode. I wonder why. Hope that doesn't affect anything. Let's see what's up with that. Add force mode. Oh, gotcha. It's like its own separate thing. I see. There's like a separate one that's like called add force. So, there you go. Impulse. Cool. Nope. Yep. All right. Supposedly this will just work. Let's find out. Let's see if we get a compiler. Oh, oops. There is no rigid body attached to the player game object. Is there really no? Oh, did I do that wrong? Rigid body? Wait, is there no rigid body? That would be shocking. Yeah, you got rigid body. Okay, I just got the wrong one. Yeah. Dope. Rigid body 2D. Force, add and force. Add force mode. Nope, wrong one. Nah. Gotta do this. I'm gonna add force. It's gotta be 2D. Alright, no misclicks. I did it. And save. Play. There it goes. Alright, buddy. Oh, what's the jump button? Oh, I don't know the jump button. Let's go project settings. Jump is space. Why aren't you jumping, little buddy? Oh, forget to set to impulse. Okay. Yay! Oh my gosh! Oh! Look at him go! Yay! I'm gonna run the same way whenever I start like jogging around the neighborhood. Just I terrify people as they sprint down the street. My arms just filling up and down like little wings. Like that Dark Souls animation, the meme one. Cool. That's awesome. Yeah, we'll probably finish out this little section of this tutorial and then call it a day. Okay, there's two problems with our jump code. It doesn't change the animation sprite when you're in the air. Yep, it allows you to jump again while you're already in the air. Oh, fantastic. To fix this, we'll need to create a ground check. This part of the graph will use a raycast. Yeah, raycast, what that is it could be a lot of things, but it's more or less you are projecting almost like down to a surface to check to see. It's really useful to do raycasting and a number of things, like you can have objects land on the ground, for example, which is kind of like we're doing now because you raycasted it to check for the surface. That's really, oh, that explanation was all that great, but hey, that's what you're gonna get till I learn more. Check back in a year's time, ask me what a raycast is. It'd be a lot better explanation than what I just gave. Okay. Okay. Circle cast. Origin, radius, direction, distance, layer mask. To remember that, I'm going to think Ordle. I need to take circle cast with Ordle. So, circle cast. And then Ordle, okay. Is it a hair mask? Yeah, okay. So the reason is origin, the source of the circle cast, in our case the player's position. Radius, the width of the circle cast, which we'll set to 0.3 for reliability. Direction, the direction of which we'll cast, in our case -1 on the y-axis. Distance, how far the circle cast will check until it stops, which we'll set to 1.1, okay. And layer mask, on which layers it should check for a collision, which we'll set to platforms only. Great. So this is really, by the way, layer masks are really important because it allows, for example, in a 2D platformer, to where your character isn't constantly like bumping into trees or bushes or those kind of things. You'd be like, hey, I just want the character to walk on the ground. I don't want them to bump into every tree that they walk past. So you'd be like, all the bushes on the bush layer, ignore them. I only check for the layer mask of ground. All right, so this is what we're looking for. Transform, get position self, layer mask, platforms. Voila. Mask. I think it'll be a get layer mask. Layer mask. It'll either be get or nope. Layer mask literal. Okay. Layer mask literal. I And I'll just go ahead and show you guys real quick. So this layer mask platforms, if we're actually in the game view, and let's say I clicked on a platform here. Oof, oops, there we go. We clicked on a platform here, the game object, you'll see this tag and this layer. Click there, there's platform. So if I change this like background or enemies, because of what we did, he would no longer be able to land on it. Like if I changed it instead of platforms to background, nothing would happen. Okay. So, got that so far. It's grayed out because it's not functioning just yet. This graph can be read as throw a ray downwards from my position, then a 0.3 thickness. Oh, I need to put that on there. 0.3, -1, 1.1. Yeah, so what's saying is the radius for the cast, kind of like almost like a flashlight lighting or aiming down. The radius, like how wide the beam is, it's gonna be 0.3. Direction is -1, so it's below the player. And the distance is 1.1, and that's like how far that flashlight light can travel. Kind of like literally casting a light. That's a good way of remembering what raycast does. But not a light. And then we want to do expose, hit, 2D, okay. This is like, hey, give me all the values of what you found whenever that flashlight hit something. Okay. Easy peasy. This is going good. Okay, so what I was saying, is there a collider? Yes, no. Yep. Oh, wow. Okay. Okay. I get you. I get what it's saying. Now we create a true-false branch here. Just bring it. We actually connect it to this. Oops, nope, that's not what I meant to do. Wait, yeah, it is. It goes. This will go here. Let's go here. So the reason we created this graph is we're making a dead end to where it will do the jump command, which is true. However, if it detects that there's ground under there, then it won't allow you to press again. Let me try this here. I want to see if this works. Oh, Yep. Okay. It's working. Oh, that's interesting. I wasn't able to jump off those spikes, which means... Yeah, okay, see? It's not on the layer of platform, so I can't jump again. Let's try this. But now, let's see if I set this to... the spikes to being 1, 2. Yeah, see I can jump now? That's because I can jump off platforms, things labeled platforms, but for example this flag, which isn't, you can't do it. Because that's what that code's preventing. But as soon as I make platforms anything but that, these spikes anything but platform, you'll be able to jump on it. Okay. Alright, now they're wanting to set the animation for it, which should be very similar to the running we just did. Love it. Okay, so animator set bowl. Make sure I get this right. Not equal. Oh, I think I got some of this a little bit wrong. Looking pretty good, okay. Okay. I should have just read it. Okay. Gotcha. This is the reason I was throwing my brain for a loop. Let's see here. So let's call this prevent double jump. Or how about double jump detection. Okay, so what they're saying is copy this yet to do the animator portion right. Hell yeah, set this here. Cool. Now I got it. Now I got it. Guys, I got it. Me so smart. Me got it. Alright. Set bool. Animator set bool. Yeah, 2 grounded. Ta-da! Saving. This works. Woo! Wee! Woo! Uh-oh. Uh-oh. Oh, he's endlessly excited. Oh, I can't take it anymore. No. No. Ah! Alright. Great. Getting closer and closer, guys. By the way, this tutorial, this got a lot of the basics of what I'll need for the game. There's just a few unique features that I need to add to this prototype, which I'll tell you about once I do this bolt tutorials. In scripting, there's a very important principle called dry. Don't repeat yourself. What we did to change jump sprite broke this principle. We copy and paste the same part of the graph twice. Now we wanted to make adjustments to our ground check code. We have to change 2 places every time. This may not seem so bad now, but what about when we'll have our enemies doing multiple ground checks too? We have to update our graphs in 3 or 4 places even every time. Yikes. Fortunately, Bolt provides a way to reuse the same graph in different places called super units. This is great. Yeah, this is a very important part. This is called, like macros, and there are things, bits of code you want to repeat. As often as you can reuse code, you should, because it's like computationally a lot on a game. So I'm glad I didn't think anything of it because I'm not a programmer, but they're totally right. Assets create flow macro, ground check. Okay. Assets create boat, flow macro, rounded. Don't want it animations, that's for sure. Music. Macros. Okay. And then what we need to do is, let's see if our flow graph's still up. It's not. We'll select player here. Alright, we'll find this right here. We'll just copy it. And grounded, paste it. And I bet I just have to drag and drop that into here. Nope. I was wrong about that. Let's see here. Cool. Oh man, this is awesome. So output Boolean grounded. Okay. Where's it? Yeah, output. Visual outputs. Oh, okay, it's looking at nesting? Nesting. No, okay. Oh! It's right there. Graph inspector. Okay. Cool. Okay. reception is... That's great. Now do I... Oh god. Can I... Oh, no, what's happening? What? Oh, what happened to my connection? Something... Collider. Grounding. Output. Ooh. No. It's like a mystery to me. That's weird that didn't pop up. It's okay though. We got it. Alright, so. Good. Good. Now we go back to player here. And delete this. I feel like such a genius doing something so simple as this. I'm like, oh, look at how clean my little graph is. Okay. Oh, they don't let me Oh, there's gotta be a way to resize that. Oh well, worry about it later. Better things to do. Cool, guys. Alright, that's awesome. Look at that. I got a little experience point. I'm a level 1 programmer. Not really. Stars. Get all the, oh. Clear instructions. Alright then. That's awesome. Okay, so let's go back to the game and just do one last task before we conclude for today. Yeah, my goal for this week is to get through all of this bolt, then kind of look through the features and I'll work on the feature list for the game, and then try to tackle it. Working perfect. This is great. Alright guys, awesome. Oh, dudettes. I'm so happy to get that done. Whew. So yeah, that concludes for today. We're just learning some visual programming so we can make the actual game itself and like a basic prototype in. I can't wait also to show off the art side because that's like where my expertise lie. And thanks for being here. Can't wait to show you more progress for the game. If you want to connect more and learn more,